We are starting, ladies and gentlemen, and kids of all ages. We are starting systems of equations. Systems of equations, which really means nothing more than you have two equations happening at the same time, or two linear equations happening at the same time. Happening at the same time. And there are multiple ways to figure out. And really what you're looking for in a system of equation, you are looking for the values that solve both equations. You are looking for the values that solve both equations, and here is, we will do it multiple ways, by the way. Here are the different ways, or a few of the different ways. Today we're going to solve them by graphing them. A little bit later, I don't know, maybe tomorrow, if I feel like it, we will solve it by substitution. A little bit later, we will solve it by elimination. If you know what those all mean. But here's the gist of what it is. Let me give you an example, and then maybe, just maybe, it will make sense to you. Oh, maybe I won't. Will I? Well, I won't. Wait, I need a pencil. I need something. I need something to write with. And I should put it right here. No, I'm not going here. Take that back. Here's the deal. So, taking a look here. The sheet I gave you. Is this the sheet I gave you? Yes. What you have is this. Let's go to practical applications later. You have two equations given for you. Like, see, for problem number 1, right? Y equals negative 7/4 x plus 3, and y equals negative 1/4 x minus 3. There is, these will both be lines. Oh boy, no, don't do that. Those will both be graphing lines. And there is only going to be one place where those lines will cross, and that's what you're looking for. Where do the lines cross? That point is your answer. Now, for those of you that like to not do straight lines, Brandt, Carter, Westfall, you know, this won't work by drawing it freehanded because you'll never get the right place. So you're going to want to use some sort of ruler. Pretend you are in 8th grade and use a ruler here. So here's the gist. And you can solve these, by the way, any particular way you like. I don't know what's going on here. Struggling. So here. These are both in slope-intercept form, so you graph them both in slope-intercept form, right, Carter, Altenburg?
Yes.
Let's do number 1 first. It crosses the y-axis at 3. What's its slope? Negative 7/4, which means it goes up and down 7/4. So let's go down 7. 1, 2, 3, 4, 5, 6, 7. Because it's going downhill, I'm going to go 1, 2, 3, 4 this way. And I am going to use a straight edge. In my book, it's this. With me, and then I am going to draw a line betwixt those two. Now, children, what you must understand, a couple of things here, is that this line represents every possible answer to this equation up here. And when you do that, you need to have arrows on both ends because that line continues on forever. If I asked you to give me the domain and the range of that line, you would tell me it is
Infinite.
all real numbers. But yes, if you're doing an interval notation, it'd be negative infinity to positive infinity. Now, once you get the first line, you then graph the second line. It's always fun if it's a different color. It crosses the y-axis at -3. It goes up 1 over 4, and again it is negative slope, so up 1 over 1, 2, 3, 4. There's that line. You know what I'm going to do? I'm going to make mine that has arrows on both ends right off the gate. And then you graph that line. And you'll see sometimes it's not absolutely perfect, but. And the place where those two lines cross, right here, this is the solution that you want, which is what? 4, -4. 4, -4. That is what you are looking for. It's not really a complicated sort of thing. How about the second one? Should we do the second one? Let's do the second one. You should be done with the second one. Well, maybe not. Should I let you do the second one? You do the second one, I'll do the second one, we'll see where we meet. -4, up 1 over 4. Is this my line, really? It doesn't seem hardly right, does it?
Isn't it? Something.
Wait, did you say this wasn't right?
No, I thought it was the exact same thing as the one before.
And then the other line is crosses that +4, and it's a -7 force. Wait, that's the same one we did before, wasn't it?
Yeah.
No, it's
1,
not.
2,
a different
3,
spot.
4,
It's not a
5,
negative
6,
1, 4.
7, 1, 2, 3, 4. Oh, look at that. It doesn't get any better than that. That point automatically goes right there no matter what. But it's close to the same answer, is it not?
It's 1 off.
And then the place where they cross is 4, -3. What else we got here? Oh, let's go to the last example there. And again, remember, you can use whatever method to solve you want. These are not in slope-intercept form, but they're in standard form. So how do we solve standard form ones?
They cover up one side and you look at the
What
other.
do we call that? X and Y
Intercept.
intercepts. So for the first one here, the x-intercept is -1. Negative, make sure you be careful. That's negative like that. The y-intercept is
-3.
so the graph of that line is second line, x-intercept is
-1.
oh great. Y-intercept is
-3.
oh great.
Same line.
Uh-oh. Uh-oh. You say,
I wonder what they.
somebody say uh-oh.
Uh-oh!
Now, that leads us to this little thought right here. Okay, when you graph two lines, there are 3 possibilities. What would those 3 be? Number 1, they never will cross. And if they don't cross, then guess what? There's
Parallel.
no, well, they're parallel, but there's no solution. If they do cross,
There's the solution.
there's one solution. And the third choice is what just happened to us. If they're the same line, then there are infinite solutions. Infinite solutions. They go on forever with solutions. That doesn't mean everything's a solution, but there are infinite amounts of solutions because it is the same line. And let us do this last one just for whatever sake or reason it is. Y is -8. Has a -3/7 slope. Means goes up 3 over 1, 2, 3, 4, 5, 6, 7. So there's this line. The second line is +9. And it has a -3/7 slope. No, 3 over 7. Sorry. Somebody said, yeah, those will never cross. There's no solution to that. There is something else they use, something about being consistent, inconsistent, and something else, but I don't think it comes up in this one. Does it? Let me look. Let's not get all crazy. All right, I think that's going to be it. I'm just going to give you the worksheet. That's all you're going to do is graph those things. There'll probably be a quiz because I don't think the worksheet will take you